Okay. So, okay. So you said that you need the information about sigma bond and pi bonds, right?
Yeah.
Okay. So now what I'll do is I'll take the example of ethene, right? Ethene is made up of CH2 double bond CH2, right?
Yeah.
Okay. So ethene has a double bond, that means it has a sigma bond and a pi bond. Now we'll try and understand how this sigma and pi bond is formed. So if we consider the central atom carbon, we know that the atomic number of carbon is 6. So the electronic configuration is 1s2, 2s2, 2p2, right? So the valence
Yeah.
shell orbitals are 2s and 2p orbitals, right?
Yeah.
Okay. So now this is actually the ground state electronic configuration of carbon, right?
Yes.
In order to form the bond, what it does, it absorbs energy and undergoes formation of the excited state. So in the excited state, what happens? It moves its electron to the vacant 2p orbital. So this was our 2s orbital and this is our 2p orbital. So the electron is moved from the 2s orbital to the 2p orbital. So this is your excited state. After the excited state is formed, what happens is it undergoes hybridization. Okay. Now, since we are forming ethene, right? We are forming ethene and the carbon to hydrogen ratio is 1 is to 2. What happens is one of the s orbital, one of the 2s orbital, and two of the 2p orbitals. They mix and recast to form three sp2 hybrid orbitals. So you get three sp2 hybrid orbitals, and this is the 2p orbital which has one electron. It doesn't participate. Make sense, Harshita?
So the 2s and the 2p it
Yes.
mixes
So what
to
happens is if we consider this as a 2s and we had three 2p orbitals. So this is px, py, and let us assume pz, right? So they would mix and recast to form three sp2 hybrid orbitals. Clear? And we will have one pure p orbital. So these are the three sp2 hybrid orbitals, and this is the 2p orbital which didn't participate. Clear?
why did the 2p not participate?
Because we needed only the availability of hydrogen was 1 is to 2,
Yeah.
right? So because the hydrogens were not
Yeah.
sufficient, so carbon had to make a compromise, and that is the reason it decided to undergo sp2 hybridization. If there were sufficient number of hydrogens that were available, carbon would have underwent sp3 hybridization. So we would have got four sp3
Okay.
hybrid orbitals. Okay.
Okay.
So now how would be the arrangement? So the arrangement would be, because we have three, you know how, what would be the bond angle?
Trigon of
Yes.
120.
Yeah, that's right. 120.
120?
Yes. So we would have 120. So basically this would be the arrangement, right? So this is
Yeah.
your 2s, sorry, sp2. This is another sp2 and this is the third sp2, right? Having a bond angle of 120 degree. And now let me consider this as the p orbital, which is not taking part. Okay. Now, since
Yes.
we
Yeah.
have how many? if you check the structure of ethene, we have two CH2s, right?
Yeah.
So the other CH2, the carbon also undergoes the same hybridization.
Yes.
Okay, and we have three sp2 hybrid orbitals, right? And we have a pure p orbital.
Yes.
Okay, now understand, this has one electron, even this has one electron, this has one electron, and this has one electron, right? Does
Yeah.
that make sense? Okay.
How does it? So each one of them have one electron.
Yeah, each one of them had one electron.
Oh, okay.
Clear?
Yeah.
Now what
Yeah.
happens is this sp2 and this sp2, they overlap each other. Okay, so what happens, we get one of the sp2 overlapping another sp2. Clear?
Yeah.
Okay, and then we had this sp2 not overlapping this sp2. Okay, sorry, not, I said not overlapping. We have one sp2 here at 120, another sp2, right? This
Yep.
sp2 and the third sp2. Does that make sense? And then we
Yeah.
had a pure p orbital.
Yes.
Okay, so we have two electrons here. Is that clear?
Yeah.
Now if you check, this is called as a head-on overlap. They are overlapping head-on. They are overlapping head-on and forming a sigma bond. So this head-on overlap is called as a sigma bond. Clear?
Okay.
Right?
Yeah.
And then you have hydrogen. So even these had one electron each, right?
Yes.
And we have four hydrogen. We have four hydrogen, two on the left hand side carbon and two on the right hand side carbon. And if you check the hydrogen electronic configuration, hydrogen is atomic number 1, 1s1. So valence shell will be just 1. Clear?
Yep.
Is this understood?
Yes.
Okay. Now what happens? Now the s orbitals of, so s orbital are spherical. So the s orbital of the hydrogen overlaps the sp2 hybrid orbitals. Make sense?
Okay. Yeah.
And even these overlaps are head on.
So they all form sigma bond?
That's correct. So these are sigma bonds. These are sigma bonds.
Okay.
Clear? Now we have, what about the pi bonds? These p orbitals, they overlap parallelly. Okay,
How do they overlap?
so that is the side on overlap, the way I have shown.
Oh, okay.
Okay, they overlap side on, and that results in formation of the pi bond. Is
Okay.
that clear? So this together, right?
Yeah.
This and this together is a pi bond, one pi bond.
Okay.
Clear? So it is above, some part of it is above the sigma bond and some part of that is below the sigma bond. But together it is one pi bond.
Okay.
Clear?
Yeah. Yeah.
Any doubt?
And pi bonds only occur with p orbital?
Yes, mostly with the p orbitals, pure p orbitals. Whenever there is a, it can occur with d orbitals too, if there is a side-on overlap,
Okay. Not
right?
head on.
Not
Side
head-on. Yes.
on is
Now the
different.
thing is, S orbitals never form pi bonds because for p orbitals to form, the overlap has to be side on.
Oh, okay.
Clear? And S spherical. Spherical means there is no direction.
Yeah.
Any doubt?
Okay. No.
Sure?
Yeah.
Okay. So give me 1 minute. Give me 1 minute. I'm trying. Okay.
I have a question. So the